In this video, we're going to use the Fundamental Theorem of Calculus and the chain rule to find a derivative of an integral function. It says, given f of x below, find f prime of x. So the first thing I'm going to write is that, from previous videos, I know that f prime of x is going to equal f of x. But what I want to do is I have this natural log x up here, this function here, that I need to take care of because that's going to cause like a little chain rule issue. So I'm going to say that u of x is equal to natural log x. So I'm going to replace this upper bound with u of x. And what that does is when I take f prime of x, I can say that, and the reason we're dealing with this is we're used to just having x for the input. Well, if I got natural log x, that kind of throws a wrinkle into the situation because I'm gonna have to use chain rule on that. So I've got f prime of x is equal to, this would be u of x squared minus 9. And then dt here, okay, I'm going to be replacing that with let's see, let's write this down. This would be, the chain rule is dy over dx is equal to dy over du times du over dx. So I'm going to be replacing that when I take the derivative of this whole piece. I'm not really taking the derivative of, I'm taking the derivative with a u with respect to x. So I have this times du over dx, right? When I take this derivative, I'd be taking the derivative of u with respect to x. So I'm going to kind of put a bracket around this. So then I would have f prime of x is equal to, if I substitute natural log in here, I end up with natural log of x squared minus 9, and then this would be still times d over dx of u, which I'm going to plug in for u, that'd be natural log x. So when I take the derivative out here, I end up with 1 over x. So this would be equal to natural log x squared minus 9, and then this all would be times 1 over x. So then I end up with natural log of x squared minus 9 divided by x, which is what f prime of x is. So we had to use this little substitution up here because we have natural log x, and natural log x, when we take the derivative here, is going to cause us to use the chain rule. And so that's a little algebra manipulation so that we can use the chain rule there.